Hey tens, Ellipsis here. Today we're going to learn about the Pythagorean theorem. The Pythagorean theorem is a very simple theorem, but it's one of the most important, most fundamental theorems of all math. But what is it? Let's find out. Also, the first week of school has finished, at least for me. But I want to know how the first week went for you guys. So, give an answer for that in the comments below. Some terms to know. The Pythagorean theorem is a theorem that states a squared plus b squared is equal to c squared in a right triangle, where a and b are the two shorter sides, which are adjacent to the right angle, and c is the hypotenuse. But what is the hypotenuse? The hypotenuse is the longest side of a right triangle, and the hypotenuse is always opposite the right angle. So I have this right triangle here, and I'm just going to symbolize that by making the right angle. And let's figure out which side is the hypotenuse, or which one is the longest side. Well, we know that the hypotenuse is always opposite the right angle, as I said before, so since the right angle is here, the hypotenuse has to be this side, or this is the longest side of the right triangle. So how would we use the Pythagorean theorem? Well, let's give these sides lengths. So this side is 5, this side is 12, and this side, the hypotenuse, is x. So we want to figure out what the hypotenuse's length is. But how do we figure that out? Well, we use the Pythagorean theorem, and we're going to see about this in the next slide. So let's move on. So, how do we find the hypotenuse given the length of the other two sides? Well, we plug in the given side lengths for a and b in that Pythagorean theorem formula. A squared plus b squared is equal to c squared. And there is a song for the Pythagorean theorem, and it's so catchy that when I learned it and when I first heard that song, my classmates were stuck singing that part for a while. Yeah. So we plug in the given side lengths for a and b there, and then we solve for c. So let's try some examples. Find the length of the hypotenuse. So let's take the first one. And we see that we have been given no lengths. And that's because I want you to try and figure out which side is the hypotenuse, so you can get that into practice. So before I show you the lengths and all that, I encourage you to pause the video and find the right angle and the hypotenuse of each of these triangles. Alright, let's do it. Let's find the right angle for this one. And we can recognize the two acute angles and find out the right angle, because there can't be more than one right angle in a triangle. As another theorem states that all the angles in a triangle must add up to 180 degrees. Now, if there were two right angles, we would already have 180 degrees because 90 plus 90 is equal to 180. So we wouldn't have any room for any of these angles. And it wouldn't be a triangle. So let's find the acute angles so we can isolate the right angle. Well, we know that acute angles look quite like this, like a point, as acute means small, like a needle. So we know that this is an acute angle, and we can also see that this is an acute angle. So this is the right angle, and therefore that is the hypotenuse. Let's do the same for this one. But instead of trying to find the right angle first, let's identify the hypotenuse and then the right angle, without needing to find the acute angles, because it'll be a lot easier. Well, which one looks like the longest side? This one? No, that obviously is the shortest. This one could be the longest, but if we laid this one straight out, it would be longer than either of these two sides. So this is the hypotenuse. And if we go diagonally across from the hypotenuse, we can see that this is the right angle. So there. Let's put in the lengths for this first one here. Okay, so we want to find the length of the hypotenuse, and we found that this one was the hypotenuse, and this x also signals that. So we have the lengths 3 and 4. So we want to plug in 3 and 4 for A and B, or B and A. It doesn't really matter which order because we need to keep track of the hypotenuse. So 3, we'll put that for A, 3 squared plus 4, we'll put that for B, 4 squared is equal to C squared, or x squared in this case. Okay, so we have our equation. Now let's simplify and solve for x. Or, yeah, it would be solve for c, but since the variable is x, we're solving for x. So 3 squared is equal to 9, plus 4 squared is equal to 16, is equal to x squared. Okay, 9 plus 16 is equal to 25, that's equal to x squared. And this is a perfect square, so we just square root that, square this side. And since a length cannot be negative, we take the principal root, or the positive root, of x squared, and 25. So the answer is 5 is equal to x. And that's our answer. So the hypotenuse is equal to 5. Now, these lengths, 3, 4, and 5, and another pair which I'll show later on, are classic examples of this because they end up with a perfect square, so they end up with a rational number, unlike many other triangle side lengths. So let's do this one now. We have this, and here is our hypotenuse. So let's solve for x. Let's put 13 as A and 15 as B. And yeah, this isn't to scale, but it doesn't really matter as long as it's a triangle. But let's do it anyway. So 13 squared plus 15 squared, or it can be the other way because of commutative property, and it doesn't matter what order A and B are in, is equal to x squared. Remember, the hypotenuse is always c, so that can't be switched around. So 13 squared is equal to 169, and 15 squared is equal to 225. And that's equal to x squared. 169 plus 225 is equal to 394, and this is equal to x squared. Now, this isn't a perfect square, unlike the last one, but we can simplify it a little bit. So we square root both of them, take the principal roots, and we're gonna have to simplify it. And how we do that is we take out all the factors from this that have a perfect square. So other videos would show you a factor tree, but that takes up a lot of space. So instead, this I learned in Algebra 2, which I found pretty helpful. I put 394 here on this side, divided by the line. And it works just like the factor tree, except it takes up less space. So, what prime factors can we divide this by? Well, we can divide this by 2. That's an easy one. So, 394 divided by 2 is equal to 197. And can we divide this by one of the basic prime numbers, 2, 3, 5, 7? No, this is a prime number, so we divide it by 197 to get 1, and once we get to 1, we stop there. So now we have to look for pairs because this is a square root. This is literally 2 over here, and an invisible 2. So if this were a cube root, if we were taking the cube root of 394, then we would look for triplets, and so on and so forth. Whatever the root is, that's how many we need to look for. So we're looking for pairs of a single number, and we can't see any here. So the square root of 394 is our simplest answer. So that's what we get. And sorry about that, got a little sloppy there. But anyways, let's move on. So how do we find the length of a side given the other two side lengths, meaning one side and one hypotenuse? Well, we plug in the hypotenuse length for C, plug in the given side length for B or A, again, it doesn't really matter, and then solve for the remaining variable in the formula a squared plus b squared is equal to c squared. Or it can be any variable, this is just a baseline. So let's try some examples. And we have the lengths here, because we don't need to find the hypotenuse. But let's do that. We can see that this is greater than this, so it's a longer side. And we're finding the length of one side. So that's not the hypotenuse. This is greater than this, so that's not the hypotenuse. And by elimination, we can figure out that this is the hypotenuse. So a right angle must be here. And let's find it for this one too. Again, I would like you to pause this video and try to figure out where the hypotenuse is in this one too. Alright, let me show you where the hypotenuse is. So this can't be the hypotenuse because we're not looking for the hypotenuse. This is greater than this, so this must be the hypotenuse, and a right angle is here. Okay, so now we figured out where our hypotenuses and our right angles are. So let's plug all the numbers into the equation. let's take the first one. So let's just put this for a x squared plus 5 squared is equal to, remember, the hypotenuse is 7, and 7 is always c, 7 squared. So let's simplify that. X squared plus 25 is equal to 49. Let's subtract 25 from both sides. (49 minus 25 is equal to 24. Again, that's not a perfect square, but it was close. So let's take the square root, the principal root of both sides. And let's simplify this, if we can, by using that factor tree again. So 24 goes in the first area. We can divide this by 2, so we get 12. We can divide this by 2 again, so 6. 2 again, so 3. Sorry about that. 3 is a prime number, so we divide it by 3 and we get 1. So again, we're looking for pairs, and we can see that we have a pair of 2 right here. Okay, we can take that out and put a 2 outside, because 2 times 2 is equal to 4, and when you take the root of 4, you get 2, or the principal root, you get 2. And then the rest is going to go inside, and 2 times 3, yes, we multiply them because these are all prime factors. They are all multiplied together to get 24. We take 2 and 3, multiply them together to get 6, and that's our simplified version of the square root of 24. So x is equal to 2 times the square root of 6. Boom. Let's try the second one, and again, before I show you the steps, I encourage you to pause the video and try it out. Alright, let's do it. So we're figuring out for this side. Again, let's put x as a. So x squared plus, again, this is not the hypotenuse, this is 13 squared is equal to 16 squared. Simplify that, and we get x squared plus 169 is equal to 256. Subtract 169 from both sides, and we get x squared is equal to 87. Okay, again, that's not a perfect square, unfortunately, so let's see if we can simplify it. But first, let's take the principal root, of course. Alright, let's do that factorization thing again. Okay, 87, let's see, which prime numbers go into it? 3 goes into 87, so we put that there, and 3 goes into 87 29 times. Okay, let's see, what are factors of 29? Well, 29 is a prime number, so we just put 29 there and we get 1, and that's our signal that we're done. So we don't see any pairs in the right column here, so square root of 87 is our final answer, and x is equal to the square root of 87. So this is equal to the square root of 87. Alright, we're done. So, thanks for watching. If you liked this video or this helped you, click that like button. If this didn't help you, click that dislike button. I greatly appreciate feedback. If you want more updates on new videos, click that subscribe button and turn on notifications. If you have any questions related to this topic, please put those in the comments below. And remember, the comments section is the equivalent of a class discussion. So if you have any answers to any of the questions, you may answer those. If you have any suggestions as to how I can improve my future videos, or even on what I should do next, please put those in the comments below as well. If I like your suggestion, I'll be sure to include that in the next video and give you a shout out. See you in the next one.